from doing these problems on your own. All right, so let's look at our honors review sheet, the one where everything's all packed together. Probably need another sheet of paper. And this is your review, we'll do it however you want. So I can just start cranking through, or you can tell me, no, I want to make sure we get number 21. Number 2. Alright, so we're doing this kind of out of order, problem number 2. So when you look at this, and it says simplify, what is the first thing that needs to be done?
Factor.
Well, it sure wouldn't hurt to have everything in terms of sines and cosines. Now, the only thing that isn't already is the denominator. So cosecant is 1 over sine. So I have sine times cosine cubed minus cosine. That's where I'm at, taking care of that cosecant, getting rid of the fraction. That's where I'm at now. Any ideas on what to do now?
Cosine squared.
Yeah, I can factor the numerator. I'm looking for something here. I can definitely factor the numerator. So I will do that. So now I think that's it. So these are got the, hopefully this is going to work now. I put your reference sheet up here so you can kind of see what's. Wow. So I don't think we need it for anything we've done so far, but we may need it later. So I am going to go ahead and pull out a cosine. That's all I can take out is cosine. Oh, my reference sheet might help me with that. You're not, yeah, it's actually negative sine squared because somewhere on there, someplace, clear up at the top, it says sine squared plus cosine squared is 1. So cosine squared minus 1 will be negative sine squared. So we have sine cosine times negative sine squared. So I think about the best I can do with that would be negative sine cubed cosine in terms of simplifying it. All right, so we can do this one problem at a time like that. So anybody see something else that we need to take a look at? Yep.
I just have a general question. What is the make? Is it like multiple choice?
Yes.
It's all multiple choice?
No, it's just like the first semester. Some multiple choice and some free response. You have the reference sheet for the whole thing. You will not have your calculator for the whole
And it's
thing.
shorter because it's a senior shortened class.
Yes.
Whatever.
Yours is. The juniors is.
Do we get to know
Yours
how many
is.
questions it is?
Huh?
How many
I have no
questions?
idea.
So it's a normal. Yeah.
You do 22.
22. This is the ones with stars are calculator. So this is definitely a calculator problem. We are solving this triangle. Now, what does it mean when we say solve the triangle? Find all the sides and angles. So we are missing side A, angle B, and angle C. So those, when it says solve, that means all of those things have to be located. Now, how do I solve triangles? Law sines or law cosines? SOHCAHTOA, Pythagorean theorem, if it happens to be a right triangle, but law sines, law cosines in general. So, taking a look at the scenario, what do you think? definitely gonna be the law of cosines first, because what do I not have? I don't have a pair. So law of sines isn't gonna help me. So here we go. Law of cosines is going to say a squared equals 16 squared plus 18 squared minus 2 times 16 times 18 times cosine 47. Now, I don't know if the law of cosines is on there or not. Doesn't look like the law of sines and cosines is on there, so you're gonna have to know those two things, which you should already know anyhow. But if this looks like a foreign language to you, better review it. That's your law of cosines. Pretty easy to type in. And I'm sure you're tired of hearing me caution you about this, but don't forget to take the square root. Because when you type all that in, that's a squared. So we have to square root that, and we get 13.68. Now remember, we were solving the whole triangle. So that means that we needed A, but we also need these angles. But what do you notice now? Now I have a pair, so I can use the law of sines if I wish. It's the easiest. Sine 47 over 13.68 equals sine C over 16. Cross multiply. And then how do I type this into my calculator? Because if I type in just this fraction right here, that's going to be a decimal, and that decimal is not the answer. What do I need to do? Second sign, yep. Also, I don't know, I should have checked this before. Make sure you're in degrees. These problems are in degrees. So 16, oh wait, that's fine, 16 sine 47. And second sign now. I got 58.80. And then, once I find angle C, B is easy because they all gotta add up to 180, right? So I think B is 74.20. Okay? All right, that was 22. All right, what else do you see? It continues on to the next page up to, looks 34. Looks like the last one.
Are the answers online? Oh.
All right, so what else do we need to do? Juniors, this is your review. We're not reviewing next week.
Can I do
So you
29?
need to focus right now. Which one, 29? And seniors, you have to take this thing in a couple days. All right, so 2 root 3 minus 2i, and we're gonna write it in polar form. Now, polar form, remember, is your RCIS theta. That's polar form. Cosine I sine, that's polar form. So, this is x plus yi. This is complex or rectangular form. So if I draw a picture of this, over 2 root 3 and down 2, this would be my r. That's my radius, my hypotenuse. So if I just do the Pythagorean theorem on that, this is a right triangle. So if I just do my Pythagorean theorem, I get 4, 12 and 4, 16. So my r is 4. This is my theta. But I really can't find that one. I'll find this one first. So when you look at these numbers, that's a 30, 60, 90 triangle. And what angle, what is this one? That's the 30. That's the 30. If you divide everything by 2, then you'll see the numbers you're used to seeing. 1, root 3 and 2. So that's your 30, which means what's your theta?
330.
330. Yeah. So that's the number in polar form. That's what polar form means. All right? Yep, Catherine?
Can you do 30?
30, find the cube roots. Now this one's already in polar form, the number is in polar form. And they also want the answers in polar form. So we want to find the cube roots of this number. And cube roots mean 1/3 power. Are you doing this, Leah? Okay, I need everybody, this is a regular class period, okay? And, I mean, I hate to say this, but I have the power to expect you to take the exam, and I will do that if you're not doing the right thing. Okay? This isn't a setting all for you. Get off the schedule. It says this is a class. I'm reviewing out of kindness for your classmates. All right, so what do I do here? I need your Moiv's theorem. Luckily, it's already in polar form, so I just do it. The Moiv says 8 to the 1/3, and then 312 times 1/3, which would be 104. So my first answer is 2. Remember, 8 to the 1/3 means the cube root of 8. So this is my first answer. Now, when I say first answer, do you remember?
You plus 1.
There are 3 cube roots, and they're evenly spaced around the circle, which means they're how far apart degree-wise?
Oh, because it's 3.
Kids?
What, 20?
3 of them evenly spaced at a revolution. How far apart? 120. So with the first one, 312 times 1/3, that's the first one, is 104. Then the next one's going to be 120 more than that, which is what? 224. And the next one's going to be 120 more than that, which is 344. And then remember how we kind of checked our answers? If we go an extra 120, we're at 464. But that's too big. So if we take out the revolution, what does it bring me back to? Where I started. That should always happen. And the directions said leave your answers in polar form. That's how they come out. That's polar form. If you're going to do de Moivre, that number has to be in polar form to start. If it's not, you're going to change it, like we just did right here.
Is the whole test calculator?
No.
See, some of these are starred, but.
Yes, if they're starred, they're calculator.
So you have 2 separate.
2 pages, just like always. You got a colored page and a white page. Yeah, it's just like always. It's nothing new or fancy, except a lot of it's multiple choice. Liam?
We need number 14.
14. Find the direction angle for okay, remember that this is just a complex number, and what it's telling me is to come over 3 root 2 and down 3 root 2. This is x, this is y. The I always goes with the y. And this is the direction angle. Now, I think if you look at this problem, look at these 2 numbers, you can probably tell me how big that angle is. That's a 45. Now, 45 is not the direction angle. If 45 were the direction angle, you'd be up in quadrant 1. what is the direction angle? 315 degrees. Yep. Yep. All right, what else?
24A.
All right, this is kind of like the one we did earlier, but the one we did earlier was simplified. This is actually verified, so we know what we're supposed to be ending up with. So somehow all that's supposed to come down to cosine squared. All right, so what's your idea there? Everything sines and cosines. It's gonna be a little messy, but if I'm just sitting there trying to figure out what to do, then I probably better do this. Change everything into sines and cosines. Now, once I do that, now I have a complex fraction. So now I'm gonna multiply everything by cosine squared. And that'll get rid of the complex fraction. So I have cosine to the fourth minus sine squared cosine squared over cosine squared minus sine squared. And oh my, things are looking up. Things are looking up. What do you notice about the numerator? You can factor it. Nope, nothing cancels at this point. Nothing cancels because you can't, when you've got subtractions and adds, you must factor before you cancel. So I'm gonna go ahead and factor out a cosine squared from the top, and what's that gonna leave me with? Cosine squared minus sine squared. It will cancel with the bottom, and since I have factors, I can do that. I can cross it out,
I just can't do it.
and lo and behold, that's what I wanted,
I can watch it.
right?
Yeah.
So any problem you see like that is going to be obviously different than that, so make sure you understand like kind of the processes that were happening. Tess? What? All right. What else? Who else sees something? It's been a long time, and I didn't expect you to memorize these then, and I don't now. But when you see cosine, cosine minus sine, sine, something should click in your brain. You look up here at your sheet, and somewhere on there, it should have a cosine, cosine minus sine, sine, right there. What is that a formula for? That's a formula for cosine angle plus angle. And my angles are pi over 5 and 3 pi over 7. So this is just the worked out expanded formula for this right here. So now I'm going to add these together, get a common denominator. And this is the formula for the cosine of 22 pi over 35, is that right? If I added right? Lucy, what's your hand up for?
Will there ever be, never mind.
Which one was that I just did? Alright. Liam? 13 is a calculator problem. It says find the angle between these two vectors. Now remember, I and j are the standard unit vectors, so v is just the vector 2 comma negative 3, and u is the vector negative 1, 1. So those are our vectors. Do not let the notation bother you. I is the horizontal unit vector over 1, j is up 1. So if you have 2 i's and negative 3 j's, that's how you're moving. All right. Well, there are lots of ways to do this, but I think I'm going to do what I wrote on Josh's pants. I'm going to use the vector dot product. How do I find a dot product? Well, I multiply x times x, y times y, and add them up. That's one way of finding a dot product. The other way of finding a dot product is to take the magnitude of the first vector, which is the square root of 13, times the magnitude of the second vector, which is the square root of 2, times the cosine of the angle between them. Remember, the physical concept of work is an application of the dot product. Force times distance times cosine of angle between. In terms of vectors, it's just magnitude times cosine. These are both dot products. So I can set them equal to each other. So negative 5 is equal to root 26 over cosine. So negative 5 over root 26 is the cosine of the angle. Second cosine, negative 5 divided by the square root of 26. The angle between them appears to be 168.69 degrees if I typed it in correctly. All right, so remember what the purpose of review is. I'm jogging your memory now. You don't even know what you need to go back and review. All right, who else?
Would you like to use both view sheets?
Huh?
Would you like to use both these?
Oh, let's start on this one first. This is way more focused on yours. Lucy?
Do you do 24B?
24B is another verify. So that means I have to simplify one side into the other side. So 3 sine squared plus 4 cosine squared equals 3 plus cosine. Okay, well this is very, very, very simple, because what do we know about sine squared plus cosine squared? Oh yeah, the very first thing right there, sine squared plus cosine squared. So, if I think about what this means, you don't have to write all this out, but doesn't this mean sine squared 3 times and cosine squared 4 times? And each pair, so that and that makes 1, that and that makes 1, that and that makes 1, so altogether I've got 3 plus that extra cosine squared. Perfect example of a super simple problem that you allow to scare you. Just think about it. That's don't be scared. Jump in. All right, what else? Oh, it's lunchtime. Okay, so when you come back from lunch, I want you to take your sheet with you. When you come back, have some questions prepared. Have some questions ready.